All right, so in this video, we are going to practice converting between linear systems of equations and augmented matrices. So let's start out with this example. Convert the linear system into an augmented matrix. Okay, now in doing so, let's first figure out the number of rows and columns our augmented matrix is going to have. Well, because we have three equations, this tells us we're going to have three rows. In this case, we have two variables, x1 and x2. And because we have two variables, this means we're going to have three columns. Right? The extra column is reserved for the numbers we have on the right-hand side. So we're going to construct a matrix with three rows and three columns. Right? Each of the three rows are going to correspond to each of our three equations, respectively. And the first column of our matrix will correspond to the coefficients in front of x1. The second column will correspond to the coefficients in front of x2, while the final column is going to correspond to the numbers we have on the right-hand side. So with that in mind, let's fill in our matrix, starting with the first row. Now for the first row, we're looking at our first equation, right? And as for the first entry, we're looking for the coefficient in front of x1, which in this case is a 3. As for the second entry, we're looking for the coefficient in front of x2, which is -2, right? Make sure to take into account the sign, right? Because that's important. As for the number on the right-hand side, that's a -1. And so that's it for the first row. As for the second row, we're looking at our second equation, right? So starting with the first entry, we're looking at the coefficient in front of x1, which is a 4. For our second entry, we're looking at the coefficient in front of x2, which is a +5, right? So it's a +5. And as for the number on the right-hand side, that's a 3. Okay, and for our third row, we're looking at our third equation. The coefficient in front of x1 is a 7, the coefficient in front of x2 is 3, and our number on the right-hand side is a 2. So yeah, this would be our augmented matrix. Okay, so now let's look at another example. Convert the linear system into an augmented matrix. Okay, now to start, let's figure out the number of rows and columns our matrix is going to have. And because we have three equations, this tells us we're going to have three rows. And notice we have three variables in this case. Right, we have x1, x2, and x3. Because we have three variables, this means we're going to have 4 columns. Right? Because the extra column is reserved for the numbers on the right-hand side. So let's construct a matrix with 3 rows and 4 columns. The rows of our matrix correspond to the three equations. The first column will correspond to the coefficients in front of x1. The second column will be the coefficients in front of x2. The third column, the coefficients in front of x3. And our fourth column is reserved for the numbers on the right-hand side. So now let's fill in our matrix, starting with the first row. Right, as for the first row, we're looking at our first equation. So the coefficient in front of x1 is a 2. But what about the coefficient in front of x2? Well, in our first equation, there is no term that contains x2. But you can think of it as though we have a +0 x2. Because if we had a +0 x2, this would be the same thing. So really, the coefficient in front of x2 is a 0. And the coefficient in front of x3 is a 2. And the number on the right-hand side is a 1. So that completes the first row. Now let's move on to the second row. Now in the second row, we're looking at our second equation. And to start, the coefficient in front of x1 is a 3. The coefficient in front of x2 in this case is a -1, right? Because technically there's a 1 there. So it's -1. The coefficient in front of x3 is 4. And the number on the right-hand side is a 7. Okay, Now moving on to the final row, we're looking at our third equation. Right, so the coefficient in front of x1 is a 6. The coefficient in front of x2 in this case is a plus 1, right? Because again, there's a 1 there, so we have a coefficient of 1. The coefficient in front of x3 is a minus 1. And the number on the right-hand side is a 0. So this would be the augmented matrix for this system. Right, so now let's move on to our next example. Convert this linear system into an augmented matrix. Now to start, we know that since we have 3 equations, we have 3 rows in our augmented matrix. And since we have 5 variables, we're going to have 6 columns. Right? The extra column is reserved for the numbers we have on the right-hand side. So really, let's construct a matrix with 3 rows and 6 columns. The 3 rows of our matrix corresponds to the 3 equations. The first 5 columns correspond to the coefficients in front of each of our variables, right? So the first column will correspond to the coefficients in front of x1, the second column the coefficients in front of x2, x3, x4, and x5, right? And our final column is reserved for the numbers on the right-hand side. So with that in mind, let's fill in our matrix. Starting with the first row, we're looking at our first equation, right? And the coefficient in front of x1 is a 1. The coefficient in front of x2 is a 2. And what about the coefficient in front of x3? Well, in our first equation, there is no x3 term. So we can think of it as though we have a plus 0 x3. And so the coefficient in front of x3 is really a 0. So for x4, we have a minus 1. For x5, we have a plus 1. And the number on the right-hand side is a 1. Now let's move on to our second row. For our second row, we're looking at our second equation. So what's the coefficient in front of x1? Well, in our second equation, there is no x1 term. So the coefficient is going to be 0. Right? The coefficient in front of x2 is a 3. The coefficient in front of x3 is a 1. What about the coefficient in front of x4? Well, we see that there is no x4 term here, so it's going to be a 0. The coefficient in front of x5 is a minus 1. And the number on the right-hand side is a 2. So that completes our second row. As for our third row, well, we don't have an x1 term, so we're going to have a coefficient of 0. And we don't have an x2 term either, so the coefficient is going to be 0 there as well. Right, and as for x3, well, we have a coefficient of 1. And as for x4, well, we have a coefficient of 7. And we don't have an x5 term, so that's just going to be a 0. And the number on the right-hand side is 1. So this would be the augmented matrix of this system. Okay, let's move on to our next example. Convert this linear system into an augmented matrix, right? That was good. Okay, but really, it's going to work the same way as we've been doing it, right? Since we have 3 equations, we know we're going to have 3 rows. In this case, we have 3 variables, x1, x2, and x3. So because we have 3 variables, we're going to have 4 columns, right? The extra column is reserved for the numbers on the right-hand side. So let's construct a matrix with 3 rows and 4 columns. And let's keep in mind that the 3 rows of our matrix correspond to the 3 equations. What about the columns? Well, we know that our 3 variables are x1, x2, and x3. And our first column is going to correspond to the coefficients in front of x1. The second column will be the coefficients in front of x2. The third column will be the coefficients in front of x3. And the final column is reserved for the numbers on the right-hand side. Okay, so let's fill in our matrix. Starting with row 1, we're looking at our first equation. The coefficient in front of x1 in this case is a 1. But what about the coefficient in front of x2? Well, in our first equation, there is no x2 term, so it's going to be a 0. Similarly, there isn't any x3 term in our first equation, so that's also going to be a 0. The number on the right-hand side is a 7. Right? You can think of this as though it's saying 1x1 plus 0x2 plus 0x3 is equal to 7. And that's precisely what this is. Moving on to our second row, we're looking at our second equation. We see that there is no x1 term in our second equation, so this is just going to be a 0. The coefficient in front of x2 is a 1. And, well, there is no x3 term, so it's going to be coefficient of 0. The number on the right-hand side is a 1. And so the way you could look at this is though it's saying 0x1 plus 1x2 plus 0x3 is equal to 1. That's precisely what this second equation is saying. Okay, and now moving on to row 3, well, we're looking at equation 3. So we see that there are no x1 or x2 terms here, so those are both going to be 0. The coefficient in front of x3 is a 1, so that's just a 1. And the right-hand side, we have a -5. So this would be the augmented matrix for this system. Right, and yeah, that's the idea. So now, let's look at another example. Convert the augmented matrix into a linear system of equations. Now to start out, let's remind ourselves what the rows and columns represent. Right, the first row corresponds to the first equation, the second row to the second equation, and the third row to the third equation. The first column corresponds to the coefficients in front of a variable I'll call x1. The second column corresponds to the coefficients in front of another variable I'll call x2. But remember, the last column is reserved for the numbers on the right-hand side of each of our equations. Right? And what might be helpful here is to draw a little divider to indicate that we really have an equal sign here. Right? This is the right-hand side of each of those equations. But now, really, all it is 2x1 plus 0x2 equals 0. This is precisely what our first row is telling us. And for our second row, well, we have 3x1 minus 4x2 equals 0. As for our third row, this is really 0x1 plus 1x2 equals 1. Right? So just translating from here to there. But really, we could clean this up a little bit if we wanted to. The first equation is just 2x1 equals 0. And our second equation, we could keep it the way it is. As for our third equation, we could clean this up and just say x2 equals 1. So this right here is our linear system of equations. And notice I've lined up the variables neatly, right? And this tends to be a good habit to do. So yeah, this completes this example. Now let's move on to our next example. Convert the augmented matrix into a linear system of equations. So let's first remind ourselves that each of the 3 rows correspond to 3 equations. Right? And the first column corresponds to coefficients in front of a variable. I'll call it x1. The second column corresponds to coefficients in front of another variable. I'll call x2. The third column will correspond to coefficients in front of a variable I'll call x3. And remember, the final row is reserved for numbers on the right-hand side of each equation. Right? And I'm just going to add this little divider here because it's, I don't know, that was good. All right, but now let's figure out what each of these equations are going to be. Well, for our first equation, it's just going to be 3x1 plus 0x2 minus 2x3 equals 5. And that's it. For our second equation, it's 7x1 plus 1x2 plus 4x3 equals -3. For our third equation, it's 0x1 minus 2x2 plus 1x3 equals 7. So this is our linear system of equations. But we could clean it up a little bit. Let's just rewrite our first equation as 3x1 minus 2x3 equals 5. As for our second equation, we could just get rid of the coefficient of 1 and write this as 7x1 plus x2 plus 4x3 equals -3. As for our third equation, well, really, we can just write this as -2x2 plus x3 equals 7. Right? So notice I've kept all my variables aligned just because it's a good habit to get into. So yeah, this right here is our linear system of equations. So yeah, that's it for this example. Now let's move on to another example. Convert the augmented matrix into a linear system of equations. So to start out, we know that the rows correspond to our equations. So the first row will be our first equation. The second row will be our second equation. Okay, and as for the columns, we know our first column will correspond to coefficients in front of a variable. I'll call that variable x1. The second column will be coefficients in front of x2. Third column, coefficients in front of x3. Fourth column, coefficients in front of x4. But remember, that last column is reserved for numbers on the right-hand side of each equation. And I'll put a little divider there just because. Okay, now let's write down each of our equations. As for our first equation, well, we see it's going to be 7x1 plus 2x2 plus 1x3 minus 3x4 equals 5. As for our second equation, it's going to be 1x1 plus 2x2 plus 4x3 plus 0x4 equals 1. Right, and we can clean this up a little bit, and I'm actually not going to rewrite it all because you don't really have to, it's just you can. But we know that plus 1x3, I'll just get rid of the coefficient of 1 there. Also get rid of the 1 right here. And we have a plus 0x4 here, so let me just get rid of that. So yeah, this right here would be our linear system of equations. So yeah, that's it for this example. And let's look at just one more example. Convert this augmented matrix into a linear system of equations. Okay, now let's remember that each row corresponds to an equation. Our first column will correspond to coefficients in front of x1, second column coefficients in front of x2, third column coefficients in front of x3, fourth column coefficients in front of x4, and remember the final column is reserved for numbers on the right-hand side of the equation. Okay, now let's write down each equation. Starting with our first equation, we see that it's going to be 1x1 plus 0x2 plus 0x3 plus 0x4 equals 7. Now, you could probably easily see that as just x1 equals 7. x1 equals 7. As for our second equation, we see it's going to be 0x1 plus 1x2 plus 0x3 plus 0x4 equals -2. Right? You could probably immediately see that as x2 equals -2. As for our third equation, well, we have 0x1 plus 0x2 plus 1x3 plus 0x4 equals 3. That's just going to be x3 equals 3. For our fourth equation, it's 0x1 plus 0x2 plus 0x3 plus 1x4 equals 4. Or it's just going to be x4 equals 4. So this right here would be our linear system of equations, represented by this augmented matrix. So yeah, that's the idea of it. And yeah, that's pretty much it for this video.